Kicking off the show with our friends from Fresno State Physics Outreach. We are here today with Professor Don Williams.
Hey, Emily, good to see you.
Good to see you. So you have a student. He's off camera. He's going to join us later.
He's going to come a little bit later.
So we're just with the professor today.
We're going to do some physics with my student here.
Okay.
So I want you to hold your hands out here.
What is the principle we're talking about today?
Okay, I want you to feel that.
Okay.
And we're feeling that. And you think that weighs heavier, don't you? Say that's heavier, right?
It feels heavier, for sure.
Put that on the scale by itself. And those folks out there can see that's 1 Newton. And guess what? Put that in there. It's exactly the same.
What?
It's exactly the same. Emily, they weigh the same. They're different densities.
Okay,
remember that word?
That's what we're talking about today,
that's
density.
One of the things we're going to look at is the idea of density and when the things float and sink, right? The density, as you can imagine. So you're probably guessing, is that going to probably sink?
Yes, that's going to
Now,
sink.
I got to be kind of careful. I got to kind of set it in here.
We do break things sometimes.
It is. It's going to, but guess what?
Yeah,
Watch
that fell
this
to
one.
the bottom.
Watch this one.
But they weigh exactly the same.
They weigh the same, but see, they're a different density. It's like when you can make a boat with a hull.
Right,
you know what I mean?
Yes.
The exact same thing, the exact same concept. Now, I also brought some different kind of water here.
Okay.
This is actually, it's not true ocean water, but we made it like ocean water.
So it's salty.
Right, it's salty.
Let me
My
taste it.
technician
No, I'm
made it.
kidding.
Yeah, really. Now, you've tasted ocean water. You're not salty. It's very salty.
It's very salty.
It's very salty. All right, you see how that kind of floats?
Yes.
Let's see if this floats higher or lower in that. Let's see if we can tell. It might be kind of hard to tell. Let's see, let's look at that.
Okay.
And then let's look at this.
I think it's lower.
You think it's a little bit lower? I think it might be. Let's take a piece of wood and we'll do some other stuff in a little while.
Okay.
Because I want to put this away so we don't have to have that away. Let me ask you this. What do you think happened to a golf ball if I put it in there?
Oh, it's going to float.
You think it's going to float?
Ah!
Come on, you know the golf. You can sit
I
over
was
there.
a golfer, too.
You know they're all at the bottom of the pond, right?
Oh, yeah, that's right.
All right. Now, what do you think about a wiffle ball?
Oh, that's going to float.
That's going to float. Exactly.
There we go.
You sure?
I mean, I don't know.
Yeah, it is.
Okay.
Because it's still made out of plastic.
All right.
Overall, the plastic is less dense than water. Less dense than water.
Oh, okay.
Now,
so you have to be more dense than water to sink.
You got it.
Got it.
And you can imagine if you just match the density, then you stay level. Like when you blow your air out and you change your density. Have you ever done that? And you sink. Because you become more dense.
So we talked about this when I was doing my scuba certification.
There you go. I got a scuba diver.
And that's how you get yourself down to the bottom of the ocean or the bottom of wherever.
You blow your air because you become more dense.
Look at me. I was learning science before I even knew it.
Exactly.
All right, what's the next one?
So you're familiar with that pumice type stuff?
Oh, yeah,
volcanic
for
rock.
the
Of course,
heels of my
that'll
feet.
float, right?
Okay.
Now, I got all kinds of different woods here. They'll all float. That looks like, that's walnut, I think. I think that's oak, that's pine. But take a look at this piece of wood. Get ready.
Was that redwood?
That's called, that's called iron, that's called ironwood, and it is more dense than actual water. It has to be.
So true hardwood.
It is. It's a special wood. That's why it's called ironwood. So really all your hardwoods, walnuts and all those will basically float, right?
Okay.
All right, now let's put something else in there. Let's go ahead and use our ocean water for now.
Okay.
I'm going to take a Coke and put it in here. Now, what do you think is going to happen to a Coke? You think it's going to float? Let me make sure there's no air under the bottom of it there. Should no air. Okay, let's see what happens. Oh, it wants to float in there, doesn't it? Oh, it's floating pretty good in there, man.
It is.
In the ocean.
In the ocean, right.
You agree with that? Okay, in the ocean. Okay, now let's come over here.
What if we're in fresh water?
Let's see what happens. Now we're in fresh water. Make sure there's no bubble in there. Uh-oh. Did it sink?
It did.
You agree it floats better in there?
Why is that?
Because this water is more dense than this. So the fluid also plays an important part. The density of what you put it in. Like at the end, we're going to talk about air and hot air and all those kind of things too.
Okay, what if we had water that had some other type of sediment or something in it?
Something else, density? Yeah, it would change. It would float, things would float differently in it because it would have a different density.
Okay.
But now, wonder if you do this though. You say, well, I'm going to go with
that's my drink.
The diet drink now.
Okay.
All right, let's take a look at this. Now, I'm just going to go ahead and put it in regular water. It floats.
Oh, yes.
So,
it's because it's a part of our diet. It's a very...
Well, what's the difference in the two?
It's a light calorie drink.
Well, it has no sugar.
That's true.
That's the key. You know how much sugar is actually in there? Tons.
A lot.
That's why I always tell my student, drink that stuff, you go to the bottom of the pool. That's another way to go to the bottom of the pool, too. And then, of course, I got an energy drink that has no sugar. It'll flow, too. It'll float too. Let's see if it
that's
floats.
my other drink.
It floats too. Yeah, exactly, because it has no sugar in it. See, sugar
Interesting.
sinks. Now,
okay, this is telling us Archimedes' principle.
Exactly. Now that's leading up to Archimedes.
He didn't tell me.
Now,
I didn't know that. He told me that.
Here's what Archimedes figured out.
What did he
figured
figure out?
that to do a density, he figured out with volume. So I made a boat out of a styrofoam cup, and I put a weight in there.
Okay.
Because otherwise they would just sit on top. And I got a line there when I set it in the water. It should set right about there.
Oh, there we go.
You guys see that?
Look at our little
now,
boat. Okay.
what I'm going to tell you is let's put that, weigh our boat in here. Okay, weigh the boat like that, right? And it should weigh about 1 Newton, the folks see too. Well, we'll let that roll across the floor, that's fine. All right, now what Archimedes figured out is this amount of water that I've displaced right there will also weigh 1 Newton. So let me show you what I'm going to do. I'm going to dip some water and get it up to just that line.
Okay.
And guess what it's going to weigh?
1 Newton.
It is. It's going to weigh
as
1
much as the
Newton.
weight.
That is. So what he says is the amount of water you push out of the way, that weight of water, that's how much it pushes up on you.
This is not as dense as this, though.
That's right. That's right.
So it takes up more volume.
Yes, exactly.
Okay.
Absolutely. Absolutely. Now, let's go back to that thing where we talked about having something very dense fluid. Look what I have floating here. I actually have a steel ball that won't begin to float in water.
No.
Because water is a lot less dense than steel. But guess what? I have mercury in there. And mercury is more dense than steel. And we can actually tell by how much it floats out of there that it's quite a bit more dense. It almost
looks like it's sitting on sand or something.
It is, but it's just sitting on mercury, floating on the mercury. So you can tell by the way wood floats how dense the wood is.
Right.
If the float half
if it
submerged,
goes down a lot, it'll be really dense.
Exactly.
Okay.
Exactly.
You've got something though about air.
We do. Let's
air
get
can
this
tell
out.
us things.
Let's talk about that real quick. Now I got a helium balloon here. Okay, I got a helium balloon I'm going to hold on to.
Okay.
But I got 2 more helium balloons. Let me bring out my really big helium balloon. Oh, now I can't bring that one out.
That actually might be a good segue.
Exactly.
Do 30 seconds for me.
You got
Explain this in 30 seconds.
So see this? How that balloon will actually take off.
I don't know why that scared me.
Do you think that helium balloon will take off?
That's not going to.
How come?
More dense. The volume of the helium is too
compared to the weight of the balloon.
Compacted.
Yes.
Look at me. I'm his best student yet. Okay, but your other student, they're going to stick around. We've got some more experiments, more science experiments from Fresno State when we come back. Everybody else, stay right there. We'll be right back.
Very good.